Okay, so you are able to see my screen, right?
Yes.
Hello. Okay.
Yes.
Okay. So today, I mean, we are in the process of discussing three-phase power measurement. Okay. So we have seen wattmeter is used to measure power in single phase and three-phase circuits. So basically, wattmeter consists of two coils. One is voltage coil, and the one is current coil, right? So current coil is connected in series with the network or the load in which we want to measure the power, and voltage coil is connected in parallel across the load or the network terminals, right? And the pointer is connected to your voltage coil and your current coil is fixed. So voltage coil deflects because of the force, and obviously your pointer also indicates some reading on your wattmeter, which corresponds to the power consumed by the network, right? This all we have seen. And 2 wattmeter method, we have seen how 2 wattmeter method using 2 wattmeters, how we are going to measure power in a balanced or unbalanced network or load, right? So that also we have seen. So total power is P1 plus P2. That means reading of wattmeter 1 plus reading of wattmeter 2, that will give you the total power. So that we have already seen, root 3 VLIL into cos theta. And if the load is balanced, then we can also determine the power factor also by using this calculation, which was given as tan theta is equals to root 3 into P2 minus P1 by P2 plus P1. Okay. So these all we have seen already, right? So now we'll go ahead with our discussion. Right, calculating the difference of the wattmeter readings. Okay, so now we have seen P1 plus P2 has resulted in root 3 VLIL into cos theta, and that is nothing but the three-phase power. Now try to calculate the difference between the two wattmeter readings. That means P2 minus P1. Try to calculate P2 minus P1. You remember or not, P2 is given as, what is P2? VLIL into cos of 30 plus theta or 30 minus theta?
30 minus theta.
Okay, right. So 30 minus theta we have got, and P1 has 30 plus theta. So try to find the difference between P2 and P1. Try to calculate that.
Sir, 3 times VLIL cos theta.
3 times VLIL cos theta.
So difference.
Yeah, difference P2 minus P1 value I am asking.
Yes, sir.
Try to calculate properly. P2 minus P1.
Sir, root 3 VLIL cos.
Root 3 VLIL cos theta. So that is okay. P1 plus P2 we have already seen root 3 VLIL cos theta. So P2 minus P1, what is the value?
Root 3 VLIL sin theta, sir.
Root 3 VLIL sin theta. Is it correct?
Yes,
Yes,
sir.
sir. Yes, sir. Yes, sir. Root 3 VLIL sin theta.
P2 minus P1 is root 3 VLIL sin theta. Okay. Someone has got some different answer other than this?
No, sir.
Anyone else who got answer different from this value, root 3 VLIL sin theta?
Only VLIL sin theta.
Okay.
VLIL sin theta.
VLIL sin theta.
So VLIL sin theta, some people have got, and some people have got root 3 VLIL sin theta. So VLIL sin theta is correct, but root 3 will be there or not, we will see. Right. So if you do P2 minus P1, that is VLIL into cos of 30 minus theta minus of VLIL into cos of 30 plus theta. If you expand and do this simplification, you will get VLIL into sin theta. Right. So root 3 factor will not be present in this P2 minus P1 calculation. Okay. Right. So what is the general formula for reactive power? Three-phase reactive power, you remember? Real power, what is the formula? Real power three-phase circuit, balanced circuit, what is the formula? Total power.
Root 3 VLIL cos theta.
Yeah. So real power is root 3 VLIL cos theta. So reactive power will be root 3 VLIL sin theta. So that will be the total three-phase reactive power. But in the present situation, when you are calculating the difference of the readings of P2 and P1, you are going to get only VLIL into sin theta. That means you have to multiply the difference what you are getting from the wattmeter readings with a factor root 3 to get the total reactive power consumed by the balanced load. Okay, so that means this balanced load, what we have seen ZB at an angle of theta, is going to absorb this much amount of reactive power. That means this much amount of reactive power is being transferred from load to source and source to load. Okay, so that means you have to multiply with root 3, the difference of the wattmeter readings. Then only you will get the total reactive power consumed by the three-phase balanced load. Okay, so that means what I'm trying to say is, so using two wattmeter method, you can find out the total real power consumed by the load, total reactive power consumed by the load, and if your load is balanced, you can find out the power factor angle also. Okay, right. So all these three things we can calculate using two wattmeter method. Okay, let's see one problem based on this power measurement. Okay, so I will ask you one more question. Right, so in the present circuit, two wattmeters are connected in which lines? Wattmeter 1 is connected in line A or B or C?
Line A.
Line A. And second wattmeter is connected in line
C.
C. Right. So is it compulsory for me to connect the wattmeters only in line A and line C, or can I connect in line A and line B, and can I connect in line A and line B or not? Is it possible to measure power using that kind of connection?
Yes, sir.
No, sir.
Possible. Possible or not?
Possible, sir.
Possible. Okay. So here in the present circuit, the B phase or B line B is considered as the common terminal for the potential coils of wattmeter 1 and wattmeter 2. If I connect this wattmeter, which is connected in C, in phase B, then the common terminal will be on which line?
C.
C. So clear, na? So that means if you are connecting your wattmeter in any two phases, the other line will be considered as the common terminal for the potential coils. Okay, so there is nothing wrong. You can connect in any of the phases. Okay, in fact, you can connect in phase B and phase C also, and use your line A as your common terminal. Okay, so any combination you can use. not an issue. Okay, in all the cases, the total power will be P1 plus P2. Okay, right, whether the load is balanced or not, you will get the same reading, whatever fashion you connect. Only thing is, if you are connecting in two phases, two lines, other line should be made as a common terminal, that's all. And you should be very clear or very careful with regards to voltage what you are specifying. Here it is between A and B, so that's why the phasor voltage is VAB. Here it is between C and B, so it is VCB. Okay, right. So accordingly, the voltage which is applied across the potential coil of particular wattmeter, that will be considered when you are calculating your power. Okay. Right. So we'll see this problem. The balancer load in figure below is fed by a balanced three-phase system. Right. So that means some balanced source is there which is giving power to this balanced load. Having a voltage VAB at 230 volts at an angle of 0 degrees RMS value. It's an RMS value, it was already given, and they are considering it as positive sequence. Okay. Find the reading of each wattmeter and the total power drawn by the load. Okay, so this is the question they are asking. So if you see here, wattmeters are connected in line A and line B, and your line C is considered as the common terminal for the potential coils. Okay, so now try to write the P1 expression in terms of voltage and current and phase angles, and then calculate what is the value of P1. Try to do that. What will be the expression for P1?
VAC into IAA
Okay,
cos of phase angle of BAC minus angle of IAA.
okay, okay. So write that expression, and then the voltage, line voltage is given, VAB voltage is given. So you have to calculate what is VAC voltage, phasor value. Okay, and then right. So then you have to calculate the angles also, and then solve this. Before that, you have to find out the current, line current also. So what will be the current here?
Sir, VAN by Z.
VAN by?
Sir, Z impedance.
Yeah, 4 plus J15. Okay, right. So try to do that. And what is the phase angle of VAN?
VAN angle 30, sir.
Angle 30, plus 30 or minus 30?
minus 30.
Okay, so try to write that angle properly and then find out the current first, and then you can substitute those in your expression for P1. Okay, so how to proceed? So anyone has got the phasor current first of all? So what is the value of current IAA?
Start doing, sir.
Okay, so please do that.
Sir, 8.55 at an angle minus 105.
Okay, 8.55 at an angle of minus 105. So that is your current IAA. Okay,
Sir,
right. So what about voltage VAC? Try to write all the three line voltages VAB, VBC and VCA first, and then you can find what about voltage VAC.
So VAB is 230. VB
Okay,
is equal to 230 and VC
Yeah.
is equal to 230 at angle of plus 120.
okay, right. So what is the expression for P1? Power P1. Wattmeter
So-
reading with P1.
So VAC into IAA cos angle of voltage VAC minus angle of
Okay. So VAC is available with you or not? VAC voltage is already there with you or not? You have VAB, VBC and VCA you have. But VAC you are having or not? That means what will be the value of VAC? Is it be same as VCA or it will be different? Okay. Okay, minus means minus of VCA. So how to get in terms of phase angle? So convert VAC into VCA into VAC. What will be that? Okay, so you have voltage VAB which is 230 at an angle of 0 degrees, VBC 230 at an angle of minus 120 and VCA 230 at an angle of plus 120 or minus 240. Okay, now in the first expression for P1 it is you require voltage VAC. Okay, but you have VCA which is 230 at an angle of plus 120. So how to convert this into VAC? What we have to do? Does anyone know this?
addition, sir. Addition.
How to convert? How to know the value of VAC phasor from VCA? How to do that? Can anyone say what will be that value? Okay, so VAC will be minus of VCA. Okay, right. VAC will be minus of VCA. So how to avoid this minus? In what will be the effect of this minus in terms of phase angle? Or you try to convert minus 230 at an angle of 120 to a positive value. That means try to eliminate that minus. How to do that? Okay. Right. So VAC is equals to minus of VCA. Okay. So VCA is 230 at an angle of plus 120. Minus of VCA will be 230 at an angle of plus 120 minus 180 degrees. That means you have to add minus 180 degrees to your existing phase angle. Okay. To find out VAC. Not only minus 180, you can add plus 180 also. It's up to you. Okay. Right, so I have added minus 180. That means I am converting a negative amplitude into a positive amplitude, okay, positive value by adding minus 180 to its phase. So it will become 230 at an angle of minus 60 degrees. Okay, is it clear? Is it clear to everyone, or someone has doubt in this? Right, so now calculate IAA, which is VAN divided by Z. Okay, so VAN is already 230 at an angle of minus 30 degrees divided by 230 by root 3 at an angle of minus 30 degrees divided by 4 plus J15. So try to calculate that and check whether you are getting same answer or not. Did anyone got this answer? IAA?
Yes, sir.
Okay, so IAA is 8.55 at an angle of minus 105.1 amperes, right? So now I think you have the expression for what are the required to calculate power P1. So all those variables are available with you. So now write your expression for P1. Okay, and substitute these values in that and try to calculate P1 value. So what is the value of P1?
Minus 512.228.
You got minus 512.23. Please check one more time.
Sir, 1966.5 at an angle of minus 70.5.
Okay, so let's see that what is the value of P1, and next we will see what is the value of P2. Okay, so P1 is given as, since it is connected in phase A, so you will have IAA, and it is connected between A and C potential coil. So VAC into cos of angle of VAC minus angle of IAA. So it will be 230 is your line voltage, okay, and 8.55 is your current, cos of angle of VAC, which is minus 60 degrees. So minus 60 minus of minus 105.1. Right, so you will get 1388.1 watts. That will be your P1 reading. Right, so did anyone of you got this answer? Try to check one more time. You should get this value.
Yes, sir.
Okay, so you know VAC. Okay, so line voltage already there, which is 230, and current also you have calculated 8.55 RMS value. So cos of angle difference between those two. So if you do that, you should get 1838.1 watts. Okay, so this is your wattmeter reading of wattmeter W1 will give you this much real power. Okay, so if someone has not got, please try to do that. So you should get this answer. Right. What about wattmeter 2? What will be the expression for power P2?
Sir, V B BC into
Okay.
I B B into cos of angle
Yeah.
between angle of
Okay.
BBC minus IAB. Yes, sir.
Correct. Right. So write that expression and try to substitute those values and try to calculate what is the value of P2.
minus 512.5.
Okay. So you should get something like minus 512.5. Okay. So let's see whether we are getting that or not. Okay. So P2 is given as VBC into IBB into cos of angle difference between those two. So line voltage RMS value is same since it's a balanced load. So 230 and current will be 8.55. Cos of angle between those two, you have VBC here, which is minus 120 degrees, minus of minus IBB. You have to calculate what will be the phase angle. So it will be minus 120 added to IAA phase angle. So minus 105.1 minus 120. If you add, you will get minus 225.1. Right. So if you do this calculation, you will get minus 512.5 watts. Right. So others also please try to do that. So you should get this value. Okay. So others, anyone got this answer?
Yes, sir.
Okay. So you should get P2 as 5 112.5 watts. So now you know P1 and P2, right? So what will be the total three-phase power? It is P1 plus P2. So you have to add algebraically, taking the minus sign into consideration. So you will get 876.5 watts. Okay, so that means the three-phase balanced load, which is 4 plus J15, is consuming this much amount of total power. Okay. Right. So is it clear to everyone, or anyone has doubt in this problem?
Sir, how we get VBC and VC
Yeah.
equal to 230 at an angle of minus 120?
Which
Sir,
one? VBC and VCA.
VCA. Yes, sir.
Right. So if you see here, they are saying it is as a positive sequence, and they are giving a voltage VAB as 230 at an angle of 0 degrees. That means line voltage existing between AB is 230 at an angle of 0 degrees. So positive sequence means after AB, BC will be 120 degrees lagging with respect to AB. Okay, so that means you should add minus 120 to VAB phase angle to get VBC. Since it's a balanced load, it was told in the question it's a balanced three-phase system, right? So your RMS value does not change. So it will be 230 at an angle of minus 120. Okay, and similarly ABC. Okay, so C will be the third line. So accordingly you can add minus 240 to 0 degrees or plus 120 to 0 degrees. So you will get plus 120 degrees, right? So how these line voltages for a balanced system phase angle is going to vary, and how your phase voltages are going to vary, that we have already discussed in the previous classes. Okay, for a star connected system and delta connected system. Okay, so maybe you have not gone through that, so please go through that, then you will understand why BC is minus 120 degrees lagging and VCA is plus 120 degrees, right? So this is the basic thing you should understand first, then only you will be able to solve this problem. Okay, so we have discussed all these things in the previous class. Okay, so any doubt? Okay, fine. So three-phase power you can calculate using this fashion. Okay, so if you want to cross check, you can change the wattmeter to phase C, and then also you can find out. Okay, so if you do that, you will get the total power again the same 876.5 watts you should get. Okay, right. So since you know the current, which is RMS value of 8.55, so you can apply I square R formula also to find out the per phase power in the present circuit. So try to calculate I square R, that means 8.55 is your RMS value. I square into R is 4 ohms, right? So try to calculate that value. What is that value? I square into R.
$292.41.
Okay, so you got something like 292.4 or something, whatever it may be. Okay, so this is your per phase power. So since it's a balanced system, your three phase power should be equal to how much?
What's this?
3 times of the value what
times.
you got. So multiply with 3 and check whether you are getting same thing or not.
Sir, 877.23.
How much?
77.23, yes, sir.
Okay, so approximately you'll get the same thing. Okay, yeah, so that is maybe based on the number of decimals you have considered. Okay, so in the 2 wattmeter method and how you have calculated, so that much difference is acceptable, right? So you are going to get the same power what you have got P1 plus P2 in the three phase circuit. So try to calculate what could be the power factor. That means using the formula what you have seen. What is the formula to calculate power factor? Tan theta is equals to
root 3 P2 minus P1 upon P.
right. So root 3 P2 minus P1 divided by P1 plus P2 you try to do and find out theta, and from that you find out cos theta.
Sir, one doubt, sir.
Yeah.
Sir, generally, the average power consumed by inductor and capacitor means zero, no, sir?
Yeah. Real power
But
consumed by
here-
inductor capacity is
here
0.
we are not considering the average power, no, sir. Then why don't we take the power consumed by 15J?
No, 15J power consumption is called as reactive power. That is not the actual true power consumption. Okay. So average power, basic definition is for one time period. For one time period, your reactive power is 0. Right. So that means if you see, you have seen in the past, so that is considered as reactive power. That reactive
Okay.
power is not the useful power. Okay.
Yes,
It
sir.
is just
So we are
circulating between the source and the
calculating
load.
only the- Yes, sir. So we
Yeah,
are
calculating only the real
the. Okay, thank you.
real power. Okay. So what is the power factor? Using that formula, root 3 P2 minus P1 by P1 plus P2.
Sir, tan theta is equal to minus 3.755.
Okay. Try to calculate theta from that and then try to calculate cos theta also.
Sir, 0.9335.
Sir, 0.255, 257.
0.257. Okay. So everyone got the same answer?
Sir, 0.9335. Cos theta equal to.
Okay. So I don't have the answer with me. So you should only say exactly what is the value. Okay. How much you got? 0.933?
5.
0.933 someone was saying, right?
Yes, sir.
0.9335. Okay, let's keep going. Someone has some other answer with you? I'm talking about cos
Sir,
theta.
So 0.257.
0.257 is one value you got, and that is cos theta only, no, not tan theta, right?
So cost it only.
Yes, sir.
Okay, so yeah, so we have how much?
0.25 only, sir.
0.257.
Okay, so someone is saying this one, someone is saying that. So let's cross check it. So can you find out cos theta value using from the load? Is there any formula which you can apply to find out cos theta angle from the load values? You know that formula or not? You don't know? Cos phi is R by Z. You remember
Yes,
that?
sir. Yes, sir.
Cos phi is for the load, cos phi is given as R by Z. Okay. We have already drawn this in the past also, that circuit, right? Phasor diagram. R will be on the real axis and X will be on imaginary axis and Z will be root of R square plus X square, right? So try to calculate R, Z and Then find out cos theta is R by Z. Calculate that value.
Yes, sir. 0.257.
0.257. What is your theta value? Theta degrees.
So 75.07.
Okay. So 0.257 maybe is correct. I think so. Right. So cos theta you can find out from the load parameters, which is R divided by Z. So you got something maybe 0.257. So you can calculate the same thing using tan theta is root 3 P2 minus P1 by P2 plus P1. You can do that. Or if you still have doubt, you can cross check it using this thing also. That means you have the voltage VAN. VAN will be having a phase angle of AB is here. AN will be minus 30 degrees, right? And AA is minus 105 degrees. So cos of angle difference between those two, that will also give you the same value. Okay. So something like cos of 75 degrees. So if you do that, you should get again same 0.257. Right. So that's it. So you can calculate your power factor from your wattmeter readings, from the load side, or from your voltage and current values also, right? So all results will be the same, right? So I hope it is clear to everyone, this problem. Okay. So you can cross check your answer whether it's right or wrong from your load parameters, from your current and their phase angles also. Okay. So anyone has doubt with regards to this problem? Okay then. Fine. So that's it. So this chapter is completed. Third chapter. It's basically deals with your three-phase star connected delta connected systems and wattmeter basic construction and power measurement using wattmeter in single phase and three-phase circuits. Okay. Right. So I will send a tutorial sheet on this, maybe from 5 to 6 problems on this. Okay. So these problems what you are seeing on the screen, same thing will be there in that, and I have added 2 or 3 more problems to that. So you can practice those for this chapter, right? So Monday you will have exam. Okay, I have already told. So I will send mail accordingly. I mean today I will send the mail. What is the syllabus and what is the timing for your exam, and how many marks also. Okay, right. So that's it for today. So Monday we will start. Monday we will have only exam. No class will be there. That means during class hours only exam will be there. Okay, right. So please prepare properly for that. So it will be for 30 marks. Okay, right. So that's it. That is like your mid exam. Okay. So single phase AC circuits alone, and try to submit your answer script within the time. Okay. I know I have already given more than the required time for your exam in the last exam. Okay. So try to make sure that you submit within the time. Okay. Okay, so that's it for today. So Monday, please prepare properly for your exam. Okay.
Thank you, sir.
Okay then.
Thank you, sir.
So you all can leave. Okay.
Thank you,
fine.
sir.
Thank you. Thank you all of you.
Sir,
Yeah. Any doubt?
yes, sir.
Okay.